I'm Ken Hansen. Been around PowerShell for a while. And the last year, been about 15 months at this place called AWS, working for Amazon. Still playing around with PowerShell, but lead program manager for the SDK and some of the stuff we're going to present today. And we coerced Bruce to come too.
I'm Bruce. I'm new. 4 weeks ago, I couldn't spell AWS. So
happy to have him. All right. This session, we're going to blow through the first little bit. The session is basically structured as why, what, and how. Why do you care about cloud infrastructure? Does it actually matter to you? What technology we're providing to help you do it easier and more correctly, and then kind of how we got that done. In theory, yeah, you can read the rest of this. You can learn. All right. Jeffrey Snover, at the beginning, said this. Yeah, he's suddenly paying attention. Says this. He says, why software is eating the world? He says he asserts software is eating the world. Mark Andreessen, which is a great comment. What occurred to me as he's talking, I'm going to go through the next 2 slides. And the reason I'm doing this is just to motivate the discussion around infrastructure. So give me 5 minutes of suspend disbelief on we will get to code, I promise. I actually believe that while it's true, the software is consuming the world, the cloud is consuming software. Even IoT devices hook back most of the time to the cloud, right? So as you continue to think about many of the examples that were articulated yesterday morning, almost all of them had a cloud back end to it. You with me? So in the end, the cloud is consuming software over time, and it will consume you if you don't join it. So here's the thing, though. Commonly understood reasons why is flexibility, cost reduction, although people sometimes don't immediately experience cost reduction until they've been in a while and figured it out. But it's definitely present. Access, you can get it anywhere in the world. It's easier to get yourself startup, so startup companies frequently do it because you can sort of get started without, buying a server and so forth. And of course, disaster recovery. These are all prominently discussed. There's a set of other things that are, I would call the frequently forgotten whys. What people don't understand is how much hardware is actually created to support the cloud. So if you take a look at the cloud infrastructure providers, they're crafting a lot of their own ICs in order to reduce cost, increase performance, and reduce power utilization, right? So what you're seeing is actually, you can get hardware in the cloud you can't get anywhere else. You get benefits from hardware, to be more specific, in the cloud you cannot find anywhere else. There's actually an ability to tune costs to a micro level. In the AWS, we have like hundreds of ways to reduce your cost, and you can actually go through and mark it. Here's how you do it. Oh, I want this time, I don't want that time. You've got bazillions of choices. Security is another one that's not frequently thought about. When we first started the cloud, maybe you guys remember this, I remember it because I'm ancient. When we first started the cloud, everybody said, well, I'm not going to go to the cloud because it's not secure, right? That was the reason. It turns out that the cloud providers like AWS have taken security so seriously for so long that they're really, really, really good at it. And they hire the world's best. So I'm not sure you're going to do any better than they are. You know what I'm saying? Yeah. We'll determine that by volume of sales. We'll just leave it at that. So there you are. We hired the best across cloud providers do. And then they're just updating software. You don't have to worry about it anymore, right? Once you start going serverless and otherwise, they just get taken care of for you. Which brings me to this other point that I haven't ever heard anybody talk about much before, which is by bringing your application and your company into the cloud world, you tend to think about things differently, more effectively. Is making sense from? So in the end, the cloud encourages a new way of programming and a new way of thinking. These are great. There is one that I think actually trumps them all, or explains them all, and that's innovation. As I call it, the master of the universe. Innovation is what's going to just drive it forward. And I'm going to make that point on the next slide just a little bit. These are the new cloud capabilities in AWS by year. They're not aggregate. That's actually new. if you want to see the aggregate, here's what that means. What that means is that in 2018, we produced 32% of the total AWS Cloud capabilities in 2018 alone, which is equivalent to the prior 2 years of work, which is equivalent to the prior 5 years of work. You with me? Nobody can afford to do this unless it's your business. So we talked to a lot of people in our executive briefing centers, and one of the things that I end up coming back to when they say, why should I go to the cloud? Why should I not go to the cloud? What are the pros and cons? It's like you can't compete with innovation at that level. What you have to do is focus on your business and innovation in your narrow segment, because otherwise it's hard to spend billions of dollars on this. So take advantage of it. That's really my plea, right? Take advantage of it, okay? Now it turns out that there's a problem. Okay, we got this great innovation. We have new stuff coming out. I mean, I sold, 32% of our total innovation was all done last year. And it produces this problem of complexity to some extent. Because we have a lot of services. It's great, but it has a side effect, which is organizing the resource and services is not necessarily easy to do. Which ones do I use? How do I use them? How do I exercise best practices? How do I expose these best practices across my organization so other people don't mess it up? In the end, we want customers to build this. I'll go back to answering that question. In the end, we want customers to build things like this, right? Beautiful, wonderful, innovative. And you can go to a lot of places which says, hey, this is my quick little Google search that says, how do I create a simple website? We have, here, you can do it in 10 minutes, simple and easy. Oh, there's just 3 easy steps because 10 minutes is way too long to spend creating a website. Or, best of all, you can do a modern, beautiful, and mobile-ready in 5 minutes website. These are the advertisements, and they somewhat fulfill the promise. The problem is that easy to start does not mean easy to finish. Easy to complete is where you got to get to in the end, not just easy to start. So you end up starting simple, and then you realize you have to add logging. So it's chewing gum and baling wire, in this case Pringle cans and tape, you end up with logging. Or you decide you have to conform to your infrastructure. I still don't know how they got that lawnmower on that truck, but that's okay. I just don't want to be underneath it, right? Or security. You realize, oh, we need to be secure. It took me a few seconds to actually say, oops, yeah, problem, right? All right. Harder. It's much harder to create a virtual private cloud and a fleet of IaaS services to back it up. I won't go through all of this, but to suffice it to say that what we actually have here is we have Elastic Load Balancer, of course. We have the notion of a region, and in AWS, regions are a little different than others, and you have multiple availability zones, each one of which is its own very robust system that sort of provides you reliability, and then you can actually scale across availability zones for better reliability and better performance. In the end, in this case, we actually have a public subnet and a private subnet. And so the actual website actually sits behind this private thing, and it's like very, very secure because you can't even get at it, right, without going through.
You should explain availability zone better.
I should explain availability zone better?
Like an entire building can be destroyed and you still have everything.
I'll repeat what he just said. Like an entire building can be destroyed and you still have, and you won't know the difference. This is true. And by the way, you'll still be in the same region, so you'll be getting very similar performance because it'll still be localized, right? Because the regions are geographically located, right? So it's a very, very robust and powerful architecture. But it looks complicated. All right, we won't go through this. So, what we've produced to try to assist is what we call the AWS Cloud Development Kit. It is, in fact, a development kit for cloud developers to assist you in doing the right thing and completing your projects sooner in the right way. Does that make sense? We're going all the way to the end here for you. Specifically, it's a a programmatic and structured place. So, in different languages, you can now actually code your infrastructure in the way you're used to. You can organize, package, compose, and deploy. We organize components to create reusable cloud infrastructure and shareable hierarchies and aggregations, shareable being the key word. So it's easy to pass around to your colleagues once you get it right. They can consume it easily because they actually understand it. We call this infrastructure in code because it's available in all programming languages. This thing is available auto-generated, and I do say eventually because we're in the process. It's in preview right now. You can handle Java, C#, Python, we'll handle Go, Ruby. These are the 9 languages that AWS supports consistently across the entire API surface. So if you want to program in AWS, you can use any of those 9 languages. We auto-generate the APIs daily. And then of course PowerShell, which is where we're most concerned about what we'll show today. So, let me flip here. Hopefully Alt-Tab is working for me. Sure. Where's my...
It's the other one. Keep flipping.
Keep flipping. One more flip.
No cheap shots about flipping off and stuff. There we go.
There we are. All right, so let's just go through an example of what I'm actually talking about here for a second. So we've gone ahead and created this thing which is a little more declarative in nature. So here we're creating what we call a stack, which is essentially the entire application. We do a basic import of the resources available to create that stack. This creates a VPC network. That's a virtual private network, which is a layer of additional security, and you can actually see that on the prior chart. We had everything within one virtual private cloud. With me? Did I say network in there? I apologize. A virtual private cloud. That's it. That's all we need to have. We have a load balancer. We've now configured the load balancer. For the fun of it, we decided to throw in a remote desktop gateway, just to add a little complication. And oh yes, this is our fleet of IIS web servers. How many would you like? How hard is that? Right? This is how we make complete easier. And then we should have a back-end SQL database. We will talk about that later. Actually, tomorrow morning, I think. Secrets Manager, secure. It's a secure store. All right. So this is our 96 lines. And what do we generate out of this? We actually leverage, and this is kind of interesting. A long time ago, AWS created this thing called CloudFormation, which is a JSON expression of your resources. And that's what people have used, and then, there are other companies have used other things, but in fact, this JSON-based, or then some go YAML-based, or whatever it is. What we decided is let's keep this here in PowerShell, and then let's generate automatically the CloudFormation template. This is what we get out of it. So just like DSC generates Moth, CDK generates CloudFormation. Now, what's cool about CloudFormation is it handles everything for us. It's highly available, very robust. If you add a component to your CloudFormation template, it gets added. It is declarative, and it's fully declarative in that if you delete something, it gets removed. He's laughing. There's a long story behind that. I knew he'd love it. So when you get out of here, you get this. Now, I much prefer typing my PowerShell than I would this 500 lines of JSON. You with me? This is why we're doing it. It's to make it so you can live in your language instead of having to learn yet another language. Right-hand side. Say? Yes, yet another YAML, right, exactly.
Yes, you have a choice, YAML or JSON.
And what I think Jeffrey is saying is, I didn't quite hear the comment, but I think what Jeffrey is alluding to is, it's code. So if you need to put a for loop in the middle of that declaration, you can. If you need a right-hand side evaluation, you can't put that in YAML or JSON or whatever it is. You can't actually evaluate stuff, right? Whereas here, you can decide how many buckets you want, how many S3 buckets I want. I'm going to have a for each around my bucket allocation, right? In this case, we could have done it with web servers, but Fleet's already a notion which scales out for us, so we don't have to. It was done, right? You can do, you can go off, you can go actually out of your code, access a database, get some configuration files, some information, apply it to the right-hand side, expression for the properties you're assigning. There's extremely high value in not only in leveraging imperative code in the way you're used to, but providing a DSL that allows you also to express what can be declaratively. That's what our attempt to do. All right. So that's what kind of the background I want to sort of set up, and now I'm going to back up a little bit and sort of say, let's sort of drill in a little bit into what sort of the CDK is and does in a more detailed level. And then feel free to keep answering questions, asking questions rather. So the CDK is a set of high-level abstractions or, quote, resources. These can be AWS buckets, virtual VPCs, blah, 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 et cetera. We call the abstractions constructs.
And something like they didn't get called providers. Somebody came up with a new word that wasn't provider. Yay!
I felt good about that. And it wasn't me that did it. Yes, we call them the constructs. They can be very simple, abstracting a single AWS resource, or they can be composed of other resources. In fact, in Java and other languages, they are essentially classes that can be built on classes and classes and classes and classes.
And in PowerShell.
And in PowerShell.
Yeah, PowerShell with classes.
Absolutely. And you can expose them via your common package management technologies and tools, right? You organize all these together in a stack, as you saw with my examples. All the resources came together in kind of a stack. And ultimately, we synthesized the CloudFormation. I think we went through this.
Yeah, so this is what the CDK, the high-level conceptual architecture of the CDK is this Venn diagram. So this notion of an app is the top layer. An app can contain multiple stacks. Each stack can contain multiple constructs. And I do want to point out that the CDK is a completely open source project. It's on GitHub. Anybody can contribute to it. There are actually a surprisingly large number of contributors to it already. We haven't released the base CDK yet, hopefully sometime in the near future, but I won't say any dates. But so people can participate and contribute to the CDK in the form of constructs. In theory, you could the underlayers that generate CloudFormation could, in theory, be replaced by an underlayer that did, say, Azure. Just as an example. So let's take a look at an example of what you would write. I mean, Kenneth showed us our ideal world in the future. We're not quite there yet. So we have an experimental prototype of the DSL today. And so here you see your app, which contains a stack. And then we have a for each loop, which is not declarative. But what this for each loop does is it creates instances of buckets. So this will create as many instances of S3 buckets as you want.
They're like a storage container for those who don't know.
Oh, yeah.
What S3 is.
So how many people here use AWS? A few.
The rest of you should repent.
Yeah. So if I'm using any terminology that like S3 or whatever, S3 is simple storage
Service.
Good.
I believe.
Yeah, there's a lot of that stuff. Everything is simple, apparently. So here's the complete script that uses that fragment, right? And it's PowerShell script. It takes parameters, and then it generates this application which has a name. And that name will be will show up in AWS. So let's try and run it. So this is something I haven't done before, is actually running cloud-based software in a demo at a conference live. Yes. So the training wheels are off. One of the things that the CDK does, actually, there's a driver function called CDK. Actually, this may be horrible. Oh no, there we go. It just gives us all the help. There are a set of basic components. CDK list will list the set of applications in the current directory. CDK synthesize, I'll show you in a second. It shows you the cloud formation that will be generated, but it doesn't actually apply it. CDK bootstrap basically bootstraps some resources in AWS, in your AWS account, that are used by the CDK to preserve state, so that they can do things like differencing and stuff. CDK deploy is obvious. CDK destroy will go and remove everything. There's nothing worse than thinking you've deleted all your resources and discover you have an EC2 instance, a VM running that's rapidly consuming all your money. I hate when that happens. CDK init just generates the basic templates for the classes. So there's my bucket stack. I don't run that directly. So we'll run the synthesis. This should take about 8 seconds as it goes off, because there's a lot of resources and things that get loaded and examined and so forth.
And this will actually be synthesized in the cloud formation.
Yes. And so you can see the individual instances that were generated from the for each loop in the cloud formation document. And so that's a reasonably, it's not as big as what Kenneth showed earlier, but it's a reasonable magnification on the amount of code. So again, that's the entire script, and it generated probably about 150 lines of cloud formation. So that's a really, really basic application. Let's move on. As Kenneth alluded to earlier, the CDK is more or less isomorphic to DSC. So where what we would call a stack is called a configuration, constructs. So a CDK construct corresponds to a CDK construct corresponds to an AWS resource. A DSE resource corresponds to a DSC resource provider, because we like providers. Composite constructs are the equivalent to a composite configuration. So you have a single construct that produces multiple resources under the covers. And then just like DSC generates MOF, AWS, the CDK generates CloudFormation. And this is sort of the flow that we just looked at. So you have your CDK application, which you run through the CDK compiler that produces the CloudFormation template, that then gets deployed to AWS CloudFormation, and CloudFormation takes care of building all the resources for you. Again, here are the basic commands. CDK lists your applications. CDK synthesize generates. I can't type synthesize, so I can only type synth. Generates the CloudFormation documentation document. Deploys to AWS, and then diff is cool because diff will show you the difference between what you just generated and what's actually up in the cloud. And that takes way too long for me to run in this.
But we'll show you what it looks like.
We'll show you what it looks like. Apparently my slide is in the wrong spot, but that's okay. So let's look at the demo with a VPC, the virtual private cloud. This one's a little bit longer. Currently, our approach, so Amazon is big into generating stuff. Everything is generated. Yeah, so everybody who builds a service provides a service description in JSON that's kind of like Swagger. And from that, we generate the CDK, the SDKs.
In all 9 languages.
In all 9 languages. And the way the prototype for PS CDK works is we take the .NET API for CloudFormation and we synthesize PowerShell modules. And if we have time, I'll show some of the PowerShell modules with the caveat that it's a prototype and maybe icky. So here's the creating the VPC network with the subnet, and there's only one NAT gateway for this VPC. Now I'm going to create an application load balancer. this is where, so a VPC should be a container, and in our prototype it's not. You actually have to pass the VPC object into the constructor, or actually as a property to the application load balancer. And then you got to an auto-scaling group for Windows servers with the EC2 instance sizes.
And what's interesting, it's worth pointing out that you can assign these things. So now you can actually assign constructs. So $LB gives you access to all the properties of the load balancer. So now you can use that later on if you have any dependencies on that information. So in fact, we end up using these things later.
And so we actually use them here from the load balancer. We're going to add a listener on port 80 because we're doing a web server.
This is another power of actually being able to handle imperative as well as the declarative capabilities that you've got.
Now, the other thing that we want to do is we're creating Windows Server instances. So we need to configure them. And so we have a script block in here that contains a set of commands that get run on the instances. It downloads and installs Chocolatey, then installs web deploy, and creates a web server, basically. And this should be DSE. Yeah. So like the synergy between DSE and the CDK is huge, and we haven't had a chance to get that worked out in the prototype yet.
And now it's interesting, worth noting, by the way, this $ASG is a reference to the
auto-scaling group.
Auto-scaling group before. So the auto-scaling group now has this script that can actually do. So if you configure the auto-scaling group, and now you actually can reference
which is one of the things that we didn't get totally right in DSE. It was difficult for a resource to use or to consume information created by a previous resource.
Right.
So that's the script, setting up a TCP IP port. Yeah, I know. I blame Nano.
Or get them more resources.
Yes. And then it returns an object that is CloudFormation, load balancer, DNS, all that sort of stuff. So let's see if we can make this one work. And again, we have the little driver JSON file. There's our VPC script, which again, I don't run directly. We'll run the synthesis. And once again, we go back to the Wheel of Fortune that makes that little that song while you're waiting. Yeah, that one.
That's right, that's one.
Yeah.
This one should take a little longer because it's doing a lot more. This actually almost completely constructs the complicated diagram that I showed earlier.
Yeah, it kind of goes
It's not 100%, but in fact, if you take a look at that, we had a set of VPC, we had a VPC, and then within it we had an auto-scaling group, and then we had private and public subnets. So that's all taken care of in just that code we just looked at, right? That complicated piece now can be articulated in PowerShell pretty neatly and very importantly shared with other people who understand PowerShell, right? So now you can be confident that, okay, Nana has created this thing. I can trust him a little bit. Oh, Jeffrey's created this one. We'll make sure we don't use that, right? And get rid of that one.
He's always leaving the ports open, I tell you.
No, but really, you're able to share and build a community around it, both internally and externally, because we follow the same language protocols. You don't have to create yet another package manager.
Right. So I talked earlier about the CDK diff. This is a CDK diff that I did, I think, this morning, that sort of shows you what's going on in this example. It's just drawing a couple of instances of resources, and then it's changing something here, kind of arbitrarily.
So it's kind of nice. This says, hey, is what I deployed, is what I have running what I expect.
Right.
Right? That could be occasionally useful. And it's interesting more for compliance checks also, right? It's like, hey, did they actually comply or did somebody mess up? Or for debugging. Okay, something's gone wrong. Let's do a CDK diff and make sure the infrastructure is configured as we expected and something didn't go haywire, right? It could be because of operator error or just, some hardware failure or something like that. But so you can automatically get this difference between the intent and the reality by using this capacity.
Sure.
Sure.
So does that mean you could like have a deployment and then bring in like Lee as a consultant to say, oh, you screwed up,
Sure.
and just modifies that code?
Yes,
Yeah.
let me rephrase that question. So does this mean that you could I'm sorry, say it one more time.
You could like bring in Lee to go consult on your security, change your scripts, and then just
Totally, yeah. So we could bring in Lee, who knows PowerShell a little bit, have him come in and consult on security. We would trust him, and update the scripts. And actually, we could just then we could do a diff before we actually deployed it, and then actually deploy it.
Yeah, and again, because we're synthesizing static machine-readable data, you can write essentially the equivalent of script analyzer that looks at the generated cloud formation and says, well, this is wrong or right, or this is not matching our best practices.
Right. So an infrastructure analyzer.
An infrastructure analyzer, yeah. And then once you
We don't have that yet.
Once you have that stuff, you can wrap it up in a construct, and now you have a reusable component that you know has passed security analysis. Speaking of creating constructs, let's look at how to create a construct. I don't know if you can read this or not. Yeah, this is an example. So this is something that we haven't wrapped in the DSL yet. This is just using PowerShell's native class capability to extend the CDK construct type. The constructor has to follow a particular pattern, which is it takes the parent object, the name of the thing that you want to construct. You can see the names in the cloud formation, and finally a collection of properties. I've leveraged my for each loop to create a whole bunch of buckets, and I'm doing something a little different here. I'm preserving the buckets in the class and providing a separate method where you can use the CDK constructs to go through and grant read-write access, or grant the access to the individual buckets. CDK buckets are interesting because the namespace is flat. A bucket name is global across an availability zone. So you have to be somewhat careful in how you generate your bucket names. And you definitely have to manage access.
So this goes back to, this is actually, there's like no magic here other than actually just, straight on PowerShell.
Right.
Using classes.
And so I've created this construct, and now this is how we're going to use the construct. This is actually a little bit of smoke and mirrors, because I don't have code that synthesizes the hello construct driver function. But this is how it, in the ideal world, this is how it works. It creates a live instance of an object, and because it's a live instance, we can call grant read to the user we're generating. So we use the user construct to generate the right identity to apply to the S3 bucket. So same. Now we're going to run it, and it'll use the PowerShell class as a construct to generate a bunch of bucket resources in 8 seconds. So here we can see the various buckets and the changes to grant the read access to the buckets.
So this is sort of just basically showing, hey, here's how you actually can participate, if you will, in that ecosystem over time in a way that's easy. We auto-generate. So CloudFormation has capabilities that span the surface area of AWS services. And we auto-generate from those a bunch of base modules for CDK that are then exposed via this JSII thing into all 9 languages, right? But then on top of that, you can both create, and we call those like, level 1 resources because they're very, specific and kind of low level. And you can create your own kind of L1 resource, or you can take existing resources and grow them to a higher and higher level by simply deriving.
Yeah, and this application also shows using a few of the other AWS resources, queues, topics within a queue, and setting up a queue subscription. Down here, we're using our composite resource. So speaking of things that you can look at, or that you can, so here's the Amazon, here's a set of modules. This is awkwardly annoying. But just to give you an idea of the set of resources that are available.
So you already have a set of, you start with a whole lot.
And includes things like code pipeline for doing DevOps stuff, data pipelines. Alexa is one of the resources, so you can do your Alexa configuration.
Do you have an Alexa app?
Yes. Alexa, reboot my server. Kinesis analysis, lambdas, support for AWS
Alexa,
lambdas.
make the error screen go away.
So there's just a ton of resources, and this all works because of the generation of the synthesis that we have. For each of the services we generate.
One way to think about this, give this in perspective, is when we first started PowerShell, we had like 100 commands, right? 200, something like that.
200.
Anyway, it took a while, and then we had this hockey stick that happened in Windows Server 2008, right? It sort of went up because everybody was required. Well, we start there because we auto-generate. Mm-hmm. So the entire service area gets covered first, and then you improve from there. So it leapfrogs your ability to get work done.
So pulling the covers back a little bit on this, we have talked about this so far, but just to reiterate. So the bottom layer is, so the drivers for a lot of this stuff are actually written in JavaScript. And it used to be that you had to write JavaScript, then you had to write .NET, like C#, and you had to write this, and you had to write that. Now what we're doing is, and this is again another open source project, is something called JSII that allows you to build a TypeScript class, not JavaScript, TypeScript, because TypeScript is awesome. Build a TypeScript class, and from that you can project language bindings for all the other 9 languages. And then from the .NET bindings, we're actually generating PowerShell bindings. And that means that there's not a lot of manual code. People just don't have to write a ton of code. And the common TypeScript drivers give you guaranteed semantic equivalency across all the languages, which is kind of cool. The CDK constructors are triples. They all take a parent property, so every construct belongs to another construct or container.
And while you don't have to know this to use it,
yes,
this is just how we're actually doing it under the covers in case you ever want to do something similar.
Or you want to contribute on the open source project, which is,
even better.
Cool. And then the set of properties that get applied to the object. I don't believe so. We're Staffen. Staffen? He was here. Right now, as far as I know, PowerShell, we're still not doing that. But I know there's some people have contributed some stuff to IntelliSense in PowerShell to start doing type inference on hash tables. So maybe.
Oh yeah, this is worth pointing out. Maybe I think we're going to have a time to mention it. It's like, look, we're using a hash table here. That's why the dash property. Over time, we'd like that to go away. Mm-hmm. But there's not an easy ability right now to define a DSL in PowerShell, so to speak. And at least, we didn't find it. Well, and so, we're going to make improvements. And then over time, as perhaps we or some other community members actually kind of add that capability, even in like a C#, just crack it open and add, then we can get rid of that. And that begins to address part of the IntelliSense, question. But in the meantime, it would still be very useful to get hash tables,
Yeah, to get IntelliSense
to
on hash
handle
tables, on pipes.
IntelliSense, and this will clean up pretty nicely.
That would help with PowerShell everywhere. And I mean, it is possible to use the infrastructure that was created for DSE to define new DSLs in PowerShell. There are a set of APIs that will let you do it, but there are a set of APIs that will let you do it. There's no declarative way to say DSE synthesizes the DSL from the metadata that's on the MOF classes. There's no other way to do that. There's no other language to do that for. And so right now the DSL capabilities are pretty much restricted to DSE. We now have a concrete case where we want to make it more general. So it's an area that will be of extreme interest to us in the future. Now you don't need to use the DSL. You can in fact do everything using PowerShell classes. Let's see if I still have...
Layer it over those resources, you're saying.
Yeah, lay it over the resources, so.
I haven't come up with a case yet why one wouldn't want to use the DSL, by the way. But in the spirit of PowerShell, which is we never get in your way, right?
Right.
You can.
Yeah, so the script that I showed earlier that generated all that stuff, this is the same thing, but is written as a class. It requires a lot more type annotations, but it's functionally equivalent. So it is entirely possible to use this, the CDK as it exists today, as long as you don't mind writing a lot of classes. The DSL gives a much better experience. And so, in summary, so we're introducing a new way to do cloud configuration through infrastructure as code. I had another slide that talked about some of the other people. There's a company in Seattle called Pulami that is doing sort of similar stuff. They're very cool technology. I suggest you check them out. They don't have a PowerShell story yet, but they should probably have one.
They don't have the auto-generated end language, and they go to something a little less robust. But it's
right. Yeah. But there's a lot of resources for the CDK itself available on the web. CDK Workshop, the scripts I've been showing are actually, I could probably show them. So this is the same thing that I was showing in PowerShell, but it's in JavaScript, or TypeScript, more specifically, using classes. The structure in other languages is more complicated. Oops. Sorry, VI, my mistake. And then here's the same thing in C#. And you can see that this is exactly...
I'm using PowerShell, I'm just saying.
Yeah. But the nice thing is that the constructs are common across all the languages,
yes.
Which means that within a development team you can write a common set of descriptions of your infrastructure and share them between different layers of your team.
At the moment you have to write those in TypeScript that are shareable across other languages.
Right.
Anything in PowerShell is shareable in PowerShell,
yeah.
Of course.
Well, actually, if you wrote a composite construct in .NET, you could still use it from PowerShell.
For example,
which is,
that's also true.
That's one of the advantages actually that PowerShell has, because it's based on .NET, is that we can consume resources through the base constructs, but we can also consume composite resources through .NET. And so you can have a mixed language environment if that's what you really want. It gives you a great deal more choice and a lot more flexibility in how you accomplish your intent. I suggest you check out the GitHub repo for some of the stuff. They have a ton more examples in different languages. Nothing there in PowerShell yet because we're not ready. Soon, I guess. I hope. And the people who are running the project are super open to taking suggestions. And so if you have ideas on how they could better factor code, for example, I'm sure they'd be very, very happy to take your suggestion.
In fact, I just want to mention, I think I'll hit your question. We started the PowerShell community was really important to us. And so we started with a pretty robust community. It's grown into this kind of amazing experience for you and for us. CDK seems to have a similar vibe to it in terms of the excitement that people are putting into it. The number of, we had 80 contributors to the PowerShell V1 before it went out. And CDK has a ton of contributors already on GitHub submitting code and everything else. So it's just, they're very excited about it. So what that means is, don't be intimidated, right? Just like in the PowerShell community, you can reach out to somebody, get educated, discover something, ask a question, or have a suggestion. Same there. It's a very open community, and the team's very responsive.
Yeah, if you even wanted to start contributing that other cloud thing, Azure resources, I'm sure that they would be willing to consider that. I know that the chief architect of it is very open. He really sees it as a way of solving a problem that is cuts across the entire industry. So
that's it. So in the end, what we're trying to do is make it easier for you to actually get to complete instead of just easy to start. We're trying to make it easier for you to do the right thing and enable other people around you to do the right thing as you move to the cloud.
Do the right thing.
In the end,
the secure thing, the efficient thing.
Absolutely. And in the end, you'll want to go to the cloud sooner rather than later, just because you want to get on that flywheel of innovation, as well as the other benefits that have already been articulated.
Suspect that
I think that's it.
That's it for us. We have a few minutes for questions. See if we have any questions.
I know we had one here. I don't know if we addressed it. Is there an AWS free tier?
Yeah.
Yes.
Absolutely.
Talk to him after. Absolutely. No, we could get you started. In fact,
you can create VMs, you can create all kinds of things for free. Buckets. It's cool.
That's a great question. We should repeat it. 4 more people should ask that question. All right.
Yes, there is a free tier on AWS that you can use to try out the SDK, the CDK.
Other questions? Thank you very much. Give you more time.